Today's topic deals with using similar right triangles. This one is a little tricky because you have to be able to look at some more complex shapes and see the different sized triangles inside those shapes. So here's a particular picture in which you're going to have to separate it out into three smaller triangles. So in this picture, this one is made up of three triangles actually. It has a small one that looks like this over here on the right, and it is C, D, B, and you can see it noted down here. The medium is right here, so it's noted over here to the side. And then there's a large one. The large one is around the outside, and it kind of looks like this. It has the right triangle, a right angle up there in the top. It is C, B, A. These are the three triangles from this picture. There's a small, there's a medium, and there's a large triangle in that picture. And you've got to be able to see each of them. What we're going to work on, though, is rotating these pictures so they're easier to visualize. So we're going to practice drawing three similar triangles, each one a little bit bigger. Right there. Those would be an example of three similar triangles. You got to practice drawing these shapes and keeping them in the same orientation so you can look at their parts correctly. Example 1 shows this nicely. On example 1, it says identify the similar triangles in the diagram. So it's already set this up for you. You can see the three triangles. Once again, the small one is over here. We have our medium one, and then we have our large around the outside. The key thing is these are already in the correct orientation. So really you should draw those three blank triangles first, just like this, in the same orientation, and then pick out the letters. So if I was working on the small triangle, I would look over here and say, all right, which one of these letters right here is on the right angle? J. So I'd label it with J. Out of these three letters, which one has the smallest angle on that little triangle? G has that smallest angle, and label it G. The other one would be F. You would repeat that process for the other two triangles as well. Once you have them drawn out separately and in the same orientation, it's very easy to complete their similarity statements. So on this one, I usually like to put the letters in order from smallest angle to largest. What's the smallest angle on this shape? G. The next biggest is F, and then J. So G, F, J. I'm going to do the same order over here. This one will go a little faster. H, G, J, and the last one will be H, F, G. That is an extended similarity statement. That means it's not just one similarity. It's showing three similarities right here. Try this checkpoint. See how you can do on it. See if you can draw the three similar triangles, small, medium, large, in the same orientation, labeled with the correct letters. For this picture, once again, you need to draw your three similar triangles all in the same orientation. So you can do a small one, a medium one, and a large one. Make sure it's obvious. If you have a long leg, keep it consistently in the same orientation. After you have them drawn, all in similar orientations, you can then label them. So start with the small one first. So here's our small one. Maybe start with the right angle. What's the right angle on this small triangle? P. The smallest angle over here is L, and then I have N. On the medium one, that's over here. On the medium one, what's the right angle? P is on the right angle of the medium one. What's the smallest angle over here? M, and then I have L. The large one's all the way around the outside. Now, it doesn't show a right angle there. However, you should realize that this is a right triangle because these numbers are a Pythagorean triple. 5, 12, 13 is one that was on that list the other day. Pythagorean triples, once again, are integers that work perfectly in the Pythagorean theorem, no decimals. So on this one, focus on the large shape. This would be our right angle. So L's on the right angle. We have M, We have n. If yours is drawn differently, you need to modify it to make more similar to this. Please take care of that if you've made a mistake. One little mistake on this medium one, we have P in the corner, we have M. This is L down here. Should be L right there. One little mistake. From there, it's easy to do the similarity statement. So this one would be L in P is similar to M L P is similar to M N L. That would be a good answer. Triangle symbols, I probably wouldn't take off for it, but they're good to have. So good to have triangle symbols. Example 2 gets a bit more challenging because it labels the sides with variables and numbers. So wants you to use that picture up there and generate the 3 triangles. Well, luckily for you, it's already generated. They're in the same orientation and they're already labeled. So they took out all the work. The question said, what's the length of the pipe? So the pipe is the piece that's right here, the piece labeled X. And you can see that it's on the medium triangle and it's on the small triangle. Here it is on the medium, here it is on the small. Now, the goal here is to find the length of that pipe, meaning we're going to have to solve for L. And there are 2 different things we could do to solve for L. Generally, though, when you have similarity going on, you use a proportion. So we're going to use a proportion to solve for X. Remember, a proportion is always a fraction equals a fraction. This is always a good place to start. Even if you don't know what you're doing, you can start with a blank proportion. What are we trying to solve for? X. Let's start with X in the upper left. Now what you need to do is pick out one of the X's to solve for. Do we want to pick it on the small or the medium triangle? It really doesn't matter if you pick the small or the medium. I'm going to pick the small because it'll have smaller numbers. So I'm going to solve for X on this shape right here. Now, this piece corresponds to the same parts on these other 2 triangles. Well, the medium doesn't have a number there. So I can't correspond to this medium one. I can kind of forget about this one. I'm not going to use this one for right now. But I'm going to correspond it over to this large shape. X corresponds to what piece on the large one? 30. And pretty much everybody's good with that. X corresponds to 30. They correspond nicely. Now once again, this comes from the small shape. This came from the big shape. So I just got to be consistent. Small over big. So on the small shape, what's another term that I have? 20. And this 20 corresponds to what on the big shape? 10 times the square root of 13. So the only hard part is maybe that on this problem. Cross-multiplying this problem is a little tricky. I'm going to give you an opportunity to try it on your own, then we'll talk about it. Solve for X. When you type this in on the calculator, you should get 30 times 20, and 30 times 20 is 600. On the other cross, you're going to have 10 square root of 13 times X. How do you solve for X? You need to divide by this term right here. Divide by 10 square root of 13 on each side. One little trick that I know, these are multiplying, so I can kind of cancel zeros. If I know this is 10, I can get rid of that if I get rid of a 0 there. So I can, in the calculator, do 60 divided by square root of 13. Try that real quick. Try 60 divided by square root 13. And tell me what you get. X is 641. That's the answer. So if you would have just typed this in, it would have been 600 divided by parentheses 10 square root 13, close parentheses. That's the proper way to enter this whole part if you couldn't remember how to simplify those zeros. And once again, you would have got the same answer, 16.641. Make sure the answer makes sense. Up here, I see units on the answer, so I need to add units on mine. The other thing, 16.641 should be less than 20. Yeah, that makes sense on the picture. If you came up with an answer greater than 20, you would know it's wrong. And if it was way less than 20, like 4 or something, you could also see that that would be a wrong answer. One common thing that people will do is they'll get a decimal for this right here. They'll put in the decimal for this, and they'll just do 600 divided by that decimal. That is not recommended. It will work a lot of the times, but the more you round in your problem, so that would have caused us to round here and then round on our final answers. You want to minimize the times that you round. If I just typed this in, I round once. If you round this first and then round your answer again, that's 2 times of rounding. The more times you round, the more inaccurate your answer will be. A lot of times, just type it in. Keep minimizing the amount of times you round your answer. Try this checkpoint now. Draw your 3 triangles in the same orientation, label them correctly, and solve for your variable. All right, so the first thing you need to do is draw your 3 triangles, all drawn similarly. This is a good method to do to keep this long piece on the bottom. Keep them in the same orientation. Be consistent. Make sure it's obvious which piece is the longer side. From there, you can go through and you can label the appropriate parts. I can see on my small triangle, my hypotenuse is 6. And on that small triangle, this longer leg is x. On the medium one, my short leg is x and my hypotenuse is 8. So once again, here's the medium one. The short leg is x, the hypotenuse is 8. I don't know this piece. I know it relates to the 10, but I don't know how long it is. On the large triangle, I know that the hypotenuse is 10, and the long leg is 8, and the short leg is 6. I know all 3 parts. I know I'm going to use this one on my proportion. Now I just got to pick, do I want to solve for x on the small or the medium? It doesn't matter. I'm going to do the small one because it has smaller numbers. I'm going to compare these 2 shapes in a proportion. I'm going to start off my proportion over here. I'm going to put my x in my upper left. So x corresponds to what on the big shape? 8. All right. Now that you have x and it's on top, that means your small stuff needs to stay on top. So that would mean my 6 goes in the other position. And 6 corresponds to what on this shape? 10. Cross multiplying, we get 10x equals 8 times 6 is 48. Yeah, you should get that quickly. Divide by 10 on each side and you get x is 4.8. On this next problem, you have the same situation. You need to draw your 3 triangles, label them, and then you can solve for the variable. Go ahead and try to draw the 3 triangles for this one, label them, and solve from there. It's the same process. Once we get square root of 60, we need to think of how to simplify this. Remember, it wants to answer in simplest radical form. The key thing when you're simplifying radicals is you are supposed to remember a special set of numbers. I'll start off this set and see if you can finish it. 4, 9, 16, 25. How are these numbers related? Those are all perfect squares. How do I get 4? 2 times 2 is 4. 2 squared is 4. 3 squared is 9. So we're down to 5 squared. What's 6 squared? 36. Any more? Ooh, nice. 69. That's pretty good. If you can get those, you're generally pretty solid. Now, the thing is, I got to focus on 60. I got to find a perfect square that divides into 60. So basically, I don't need any of the terms greater than 60. I don't need any of these right now. This list is good to be able to regenerate whenever you're simplifying bigger numbers. But right now, I'm just going to focus on simplifying based on those perfect squares. So I got to figure out of these, what is the largest number? What is the largest perfect square that divides into 60? Divides evenly into 60. So 60 divided by 49, is that a nice whole number? No. Divided by 36? No. 25? What about 16? No. What about divided by 9? 60 divided by 9, is that nice and even? No, you should know that. 60 divided by 4. Yes, 60 divided by 4. It does divide evenly. So here's how we write this out. Take note of this. You're expected to do this on quizzes and tests. What was the perfect square we just said divided into it evenly? 4. So I'll write down square root of 4. Give the board a second to catch up. Square root of 4. 4 times what is 60? 4 times 15. So I'll write both of those numbers under radicals. I keep them under radicals until I use the radical. Whenever you do this and you've picked the largest perfect square properly, you'll see that this other number is not divisible by any of these perfect squares. That's a good thing. We don't want that other number to be divisible by any of these, because that'll mean more simplifying. Right now, we should be able to deal with this little term real quick. Square root of 4 is 2. 2 square root of 15 is the simplified radical. On this last example, it says to find the clearance under an overpass, you need to find the height of a concrete support beam. So we have this set up over here. It labels a lot of important pieces for us. The only thing we need to think about is at the end, we need to know this total distance. That's our end goal. Right now, the only piece we don't know that's helpful is that x. We got to eventually try to find x in order to find that whole height. We've talked about drawing those small triangles. So everybody kind of mimic this. Get those 3 similar triangles, and I'll give you a second to see if you can label them correctly without me. On this example, make sure you can label correctly. On the smallest triangle, you need to focus down here and see what pieces you know. We obviously don't have our hypotenuse, but we do know these 2 lengths right here. We know the short leg is 5, and we know the long leg is 6.9. On the medium triangle, which is right here, it corresponds up here. There's the medium triangle. We know this piece, that's the short leg, which is 6.9. And we also know the what piece? What's the x piece called? The long leg. It's longer than the other leg, therefore it's the long leg. We don't know the hypotenuse. On the last one, the large triangle, I saw some of you mislabel this one. The large triangle, here's the picture. There's our right angle, so across from it is the hypotenuse. Do we know how long the hypotenuse is? It is 5 plus x. Unfortunately, I saw a lot of people doing 5 times x. Remember, when you're putting together 2 amounts, when you're putting these 2 together, you need to put them together with addition. We're not multiplying these, we're just adding them together. Just like if that was a 7 and you wanted to find the total, you'd say 7 plus 5. All right, which triangles am I going to use? The top 2, the small and the medium. These 2 triangles are the ones we're going to focus on. You should be able to set these up in a proportion since they're similar triangles and solve. Let's start off with our x up here. X is on which triangle? It's on the medium triangle. Okay. So we'll say it's on the medium triangle. Do I have another term on the medium triangle? 6.9. All right. So real quick, what does x correspond to? This x corresponds to that 6.9. And on the medium triangle, this 6.9 corresponds to the 5. So this is a case where the small number is not always on top. Some of you think you always have to have the small number on top. No, that's not the case. The calculator does like it if you can use your little ABC button and do small number over big. It can simplify those nicely, but it doesn't have to be that way. Cross multiply this real quick and tell me what you get for your final answer. Give me rounded to a few decimal places. 9.522. Now, does that answer the question? Does that tell us the height of the beam? So remember, the height of the beam is represented by this whole length. Do we need to subtract by 5? Ah, yeah, that's what it says. We just solved for x. I need to add the x plus 5. So to get the total, you might want to write this out to the side. To get the total, we say that 9.522, which is the x, plus 5 units. And the units are in feet. So these added together would be 14.522 feet. Make sure to have your units on your final answer. Try out checkpoint number 3. This one says leave your answer in simplest radical form. So make sure to follow those directions. Alright, so for a lot of you, you need to draw out these triangles, but you got to be able to label them correctly. Here's the small triangle. Find it in the picture. I have 2 pieces labeled. I got to be able to transfer that to my little scale drawings over here. Where does that y need to go on this picture? Where does the y need to go? There we go. The y needs to go on the hypotenuse. Where does that 9 need to go? The short leg, small leg, whatever you want to call it. This 9 is definitely on the short leg compared to the long leg. Medium triangle. We're now shifting over to this one right up here, this LMK. On that triangle right there, there's only one piece I can find, and that's LM. I can find that because I can use these 2 numbers to find it. How do I use those 2 numbers to find LM? Subtract them. 24 minus 9 is 15. Where do I place that 15 on this picture? Long leg. Large triangle now. So I'm kind of zooming out. I'm looking at around the outside edges of this shape. I see that Y right there. Where can I put Y on this picture? That's the short leg. Out of the 2 legs, that's the shorter one. And then it gives me a 24 over there. Where do I place that 24? Hypotenuse. Which triangles should I use for my proportion? I heard big and I heard small. Why do I pick those? Because they correspond to each other. Time for the proportion. So over here, I'm going to start off with Y. I'll say I'm picking the Y from this small triangle. So everything dealing with the small triangle must go on top. What does that Y correspond to on this other picture? So there's the big triangle on bottom. What else do we know on the small triangle? 9, and 9 corresponds to Y. Cross multiply. Y times Y is Y squared. And 9 times 24, 216. Pretty much everybody should be able to get to here. But now we got to deal with those radicals. Whenever you're dealing with the radicals, you got to remember the perfect squares. 2 squared is 4, and you keep going. 3 squared is 9, 16, 25, 36, 49, 64. Which one is the largest that goes into 216? 36. So a lot of you found that it was 36. If you didn't, work on that, please. So radical 36, square root of 36 times what other number? 6. And double check. Do any of these divide into 6 evenly? No. The last thing you need to do is realize that that one simplifies nicely. Don't just stop here. You got to simplify this piece. So square root of 36 is 6 with that square root of 6 remaining. There's that final answer.